is about tech-infused behavior, harnessing the power of targeted marketing in the digital era. This is going to be an insightful exploration into the fusion of technology and consumer behavior, reshaping marketing strategies in our digital era. We'll uncover the evolution of consumer habits, the role of data-driven insights, and the marketing considerations therein. Definitely an interesting ride. And guiding us through this dynamic landscape is none other than Mr. Biju Dominic, Chief Evangelist at Fractal Analytics. With a rich background in pioneering behavior architecture, Mr. Biju Dominic has reshaped decision-making paradigms globally, co-founding Final Mile Consulting and now advancing human-machine intelligence fusion at Fractal Analytics. So, ladies and gentlemen, dear delegates, discover the power of targeted marketing strategies fueled by advanced analytics and artificial intelligence as Mr. Biju Dominic shares how businesses can create personalized, engaging experiences that resonate deeply with individual consumers. So, ladies and gentlemen, let us give a warm welcome to Mr. Biju Dominic.
Hi, everyone. Whenever I go to the airports, either in Cochin or in Karipo, one of the places I go to visit is the bookstores. The Madharbhumi bookstall or the DC books stall, I go there. I flip through the Malayalam magazines, Malayalam books. And one of the things I do is to look at the cover designs. And when I look at those color designs, one thing is for sure. The design talent that is there in Kerala is outstanding. I also know one thing. Calicut loves soccer. Calicut loves the nuances of sports. Whatever I'm going to speak about the next 20-25 minutes will obviously be about tech-infused behavior. But I'm not going to speak much about technology. You heard so much about it. And right through, the questions all of you had was, we the human beings, do we have any role to play in this world of artificial intelligence and in this world of technology? So I'm trying to talk about targeted marketing. The reason why I'm going to speak about targeted marketing is there is the data that no one speaks about in the world of digital marketing. When digital advertising started in 1994, the click-through rate was 40%. 2023, with all the improvements we have made in technology, with all the understanding that we have developed of the way the machines and personalizations and other factors, the click-through rate is today is 0.35%. There has been 100 times and more reduction in our efficiency of digital marketing. Why? Why are we failing at such a humongous failure rate? And so when I'm going to speak about personalization, I'm not going to speak about the humongous technology that is there. Fractal Analytics, we lead the world in data analytics and AI. We pioneer data analytics in India, and we are the world leader today. And there is a brilliant team that we have that is puts in a huge backend to the personalization engine, and we work across 150 of the top 500 companies in the world. But I'm not going to speak about it. I'm going to speak about just one facet. Finally, when I know that there is a target audience for the bank, you are a target, you are a target, and you are a target, what do I tell you? What is the message that goes to you? Can I focus on it? Can I make it as persuasive as possible? In trying to do that, I think I'm taking you away from the world of technology. I'm going to take you to the cricket field. I know how many of you have done the mathematics of playing a cricket ball. The time the ball is bowled at about 140 kilometers per hour, the ball reaches the batsman in about 0.45 seconds. And Peter McLeod of Oxford University has done a lot of work in this area. Now today I'm interested in the brain processes that happen in those 0.45 seconds. And Peter McLeod again comes up with the answer. Because a lot of people who play cricket, and I'm sure many of you are, you says, I know what sort of a ball he's going to bowl by looking at the delivery of my hand. And within about 0.22 seconds, I actually take a call and said, I know what sort of a ball he's going to bowl. And once I know what sort of a ball you're going to bowl, I take my bat, I bring my bat, and I almost go to hit it and bring the bat exactly at the center so that the ball is hitting at the right in the center of the bat. That takes about 0.22 seconds. And now, to decide in between what shot I should play, that is taken in a matter of about 0.01 seconds. Now, this is same for any other sports. In tennis, the decision time is about 0.45 seconds. In soccer, when a penalty is taken, the time that a goalkeeper gets to take a decision is about 0.45 seconds, surprisingly. Now to me, this short decision-making time that we are able to do in the sports field has a huge significance in terms of the algorithms that I actually develop for the various technological products that I develop. Because even in those 0.22 seconds, look at the number of factors that batsman have to take into consideration. Where will the ball pitch? To what height the ball will pitch? What will be the direction? Is it going to be incoming? Is it going to be swinging away from me? Or is it going to go straight? And a whole lot of factors. All these, our brain is so powerful. In a matter of 0.22 seconds, it takes a decision. And right through, I'll tell you one thing. Whenever we've been speaking about the technology, we often forget that the most efficient machine, and when AlphaGo defeated Lee Sedol, a whole lot of people said, machines are so powerful, they are so brilliant. Yes, when also in the second game on the 37th move, when the machine did something which was so unusual, people said, yes, until then, all that the machine was taking was the moves that a human brain would do. And they said, wow, the human machine does not now need any inputs. Sorry, the machines do not need any inputs from the humans. But on the fourth game of the same match, on the 68th move, Lee Sedol made a move. And the machine didn't know what to do. And Demis Hassabis, the company that created that and more other things in AI, said one thing, which very, very rarely we hear in technological conferences. And what he says? The more we understand the inscrutable algorithms between our ears, better will be the technology we create for our machines. I'm repeating. The more we understand the inscrutable algorithms between our ears, better will be the technology we create for our machines. AlphaGo, yes, defeated Lee Sedol 4-1. But what was the energy consumption of AlphaGo? 200,000 watts. What was the energy consumption of Lee Sedol's brain? 13 watts. 13 watts. And after the game was over, all that AlphaGo could do was to play again few more games of it. But Lee Sedol got up. He said, I've lost the match. He would have had a beer. He would have ran around. Artificial general intelligence. All that we're doing is 13 watts. And the question that I have for each of the engineers sitting here would be, don't we have to learn something from that brain, which is able to do all these things just at 13 watts. Or even this wave AI, the father of it is Geoffrey Hinton and others. And where did Geoffrey Hinton actually always said that he found, for example, the backpropagation paper? Where did he find the inspiration? He was stuck, the way Minsky was stuck when we were trying to do the logical ways of doing things. But I think he said, I have now figured out how the human brain functions. He said the visual cortex are in stages. It's there. And he brought in that multiple layers into artificial intelligence. And where Minsky stopped, Geoffrey Hinton moved forward. With Demis Hassabis, Geoffrey Hinton, all the fathers of this wave of AI swears by one technology, and that is the understanding of the human brain. But we don't speak about it at all, because somewhere we believe that machine is far superior to this machine. But when you go to the sports field and other places, you start seeing the magnificence of this particular machine. And when I'm trying to speak about the digital world, I will go far more in there. Obviously, in the digital world, the key medium is the smartphone. But the question is, how much have we really studied about the smartphone? And my team did that study. We decided to go a bit deeper because we know this is going to be the medium of the future. All that we're going to speak about, whether it's ed tech, we are going to digital marketing, you talk about e-commerce, all that you're going to speak about AI. Finally, the delivery mechanism is going to be this mechanism. The question is, how well do we know this thing called the smartphone? And I think my team did a work. And I think, obviously, we had a lot of data because Fractal is all about data. But this is a primary research that was done. And I think what we found is, of course, people are spending close to 4 hours. That's the younger people. But I think there is a very interesting data point we asked. How many times do we touch a smartphone screen in a day? And we found people touch a smartphone screen 4,513 times in a day. Now, this is equivalent to people touching the remote button of a television again and again and again and again. And we know every time I touched my screen, the editorial content in front of me is changing. Now that takes us to a very important area called the context duration. And our studies said 90 percentile of the touches on the smartphones are less than 5 seconds. 95 percentile of the touches on the smartphones are less than 10 seconds. Is the last percentile, 99 and above, there, which is actually 30 seconds and above. This is a fleeting medium. Now, are we preparing with AI, with anything? But have you taken into consideration the fleeting nature of this particular medium? But no, we have taken it based on our understanding of television. 30-second commercial and edits of it. But the context duration of television is 5 to 21 minutes. And so you could afford to put a 30-second commercial and see that people will continue to watch it. But when your context duration itself is only 5 to 10 seconds, how do you put even a 5-second commercial out here? And that's why we introduced the concept of micro-stimuli. And you would have seen, this was presented at last year's ICLR conference, you know, is the #1 conference in the world on AI. And that's when the world stood up and said, oh, this is changing the way we looked at communication in the digital era. I have to completely change the way I've looked at communication. And I think, yes, we decided to understand more and more about this micro stimuli. Can I create persuasion stimuli in milliseconds? But again, to do that, I didn't go into the world of technology. I went into the world of biology. Because 1954, Nobel Prize in biology went to Nick Tinbergen. And he said, and he was studying a fish called the sickleback fish. And he looked at the reaction time and how they react around there. They see the red color, because all the males have a red color, whoop, the action happens in no time. So, to understand more about how to develop the cutting edge area in technology, we went back into the world of biology. And as we started looking at various reaction times across nature, we found one thing. The decisions in nature and in humans are all taken in milliseconds. It's just the old ways we thought that we need a long 30-second commercial to decide what should be the next toothpaste I should buy. And it fundamentally changes the way we looked at human decision-making process. And I think, obviously, biology is clearly saying it. The next question is, Biju, how do I create one? When I know, yes, nature is doing it, but can you explain a bit more about it? Again, we went back to the nature. And one of the areas we study a lot are the mating behaviors of animals and birds. Because that's where there's a persuasion stimuli, and we're trying to understand what is the power of that particular thing, and more so the neuroscience of that particular, Oops. How do I go back? Yeah. Just, you look at a peacock tail, and you say, oh, idilenda undu. And then suddenly you look closer and you realize there is so much of neuroscience around it. There's so much of design there. Every color, contour, every construct of it is actually a neuroscientific explanation of how to design a stimuli. It's just that our education system never taught us to actually go to nature, a peacock tail, and decipher how to create a technological stimuli. Because technology is only for engineers, and we will do it only in one way. But there is a nature which is so powerful around there. Or, my whole concept of microstimuli came in because Railway came to me and said, Biju, can you guys solve a problem for me? Because the single largest cause of death in Mumbai city is people cross the railway tracks, and 12 to 15 people die every day. Every day in Mumbai, 12 to 15 people die as they cross the railway tracks of Mumbai. It took me 6 months of spending hundreds and hundreds of hours on the railway tracks of Mumbai to know, why am I getting hit by a train that I can see coming in? And then we said, it's all because our brain has a problem. Our brain evolutionarily was very good in judging the speed of a rabbit and a deer that was running, and the forefathers could judge the speed of it and throw the stone perfectly and kill it. But evolutionarily, we haven't seen large objects like elephants and giraffes move fast. And we started seeing all the changes in the last 100, 150 years. In 150 years, it's too short a time to make any impact on the human brain. And so when I look at a train, a large object that's coming towards me, I'm underestimating the speed of that large object by 40%. Now, from a traditional technology solutions around there, if I had asked the engineers, they would have created a solution by saying, I know they have created, if you look at the rear view mirror of automotive cars, the brilliance of engineers have said, objects in the mirror are closer than what they appear. But has it ever appeared to you? To your brain, to your eyes? Legally, you can get away because I've shown it. So we could have put up boards across Mumbai by saying, trains are faster than what you think, so be careful. But we didn't do it. We went far deeper into the functioning of the human brain. And we asked ourselves, how does the brain judge speed? The brain judges speed with respect, always with respect to a reference point. There's no reference point as it happens when you're on a flight. You can't judge the speed of that flight. And my design team said, wow, that's a brilliant design insight. And all that my team asked is, can I provide a reference to the people on the tracks of Mumbai? And that's what we did. The extreme right of this picture is where people are trespassing. That's a constant place. The direction of the train is also constant. Now, few sleepers are left empty, 5 sleepers are painted in yellow. 15 are left empty, another 5 are painted. And when the train comes from there, you have these blobs of 4, 5. The speed at which these yellow lines disappear becomes a reference for people to judge effectively the speed of that. Where did we pick the insight for coming up with this solution? How does the human brain, the most energy efficient and the best machine that you can ever have been created so far, how does they do that job? We were asked to reduce road accidents in India. This is Bangalore-Hyderabad highway. The extreme end of it is a village where a large number of accidents are happening. We know the behavior that we need to achieve is to tell them there is a village ahead, there's an accident spot ahead, please drive slowly. But they continue to drive at 120, 140 kilometers per hour. That's when my design team and my team stepped in. We said, how does brain judge speed when I'm driving? I don't look at my speedometer. How does my brain decide whether my legs should be in the accelerator or on the brake? That's not a conscious decision. We went deeper into the construct of the brain and we realized it's how things are going past us. So my design team said, let's play a trick on that. And that's exactly what we did. We have these white lines, obviously with the distance that is begins. But as it approaches the danger spot where we want people to slow down, the distance between these white lines have been reduced. So what it does to you, the white lines are moving, your leg is on the accelerator, but suddenly the white lines are moving faster than what it does. Automatically, your leg moves from the accelerator to the brake. And speed gun studies showed us that I think people reduce the speed by 30 to 32%. The more important is, I think, keep your accolades for this. We took the first railway one at Vadala because that's where the death rate was going up the highest. In that 800-meter stretch, there were 17 deaths in 6 months, had gone to 23 deaths in 6 months, 40 deaths in 1 year in that 800-meter stretch. But the next 6 months, we did it, their death rate came down to 9. And obviously people asked, and I know you would ask that question, Biju, will people get used to it? We said, let's put it up for 6 more months. And the next 6 months, the death rate came down to 1. A 75% reduction in the biggest cause of death in Mumbai city. Look at what we have done to the road accidents in India. Road accidents in India causes India 3% of its GDP. Even if we manage to reduce the accidents by 50%, this one project alone, because coming from the deep understanding of the way the human brain functions, adds 1.5% to the GDP of this country. And that's the significance of the change that we can bring in when we bring in the power of the greatest machine that we ever created, of the human brain, into what we do. Today, as you move forward, my request is, it's high time, somewhere deep behind the technology, but that you are using that technology to develop what? The same old thing which the television industry was using? You need to rethink, because the medium, of course, has changed, and as the context duration has changed. I think what I would, and I was having conversations with your colleagues around there, and one of the things I believe what is missing today is our inability to question the status quo. In colleges and in others, what we need to raise are kids who can ask questions. With ChatGPT providing all the answers, my last column in my newspaper, some of you would read my column in Mint, all that I said is, what we need are questions. Because machines cannot create questions. They can give answers or the best ability, but the machines cannot create questions. So what should humans do? Raise the most important question that you can, most intelligent question that you can raise, which means the whole education system has to go away from trying to vomit out what I learned, which anyway the machine is doing now, to creating questions in people's mind. We have to look at the way communication has been looked at. The past, almost 100 years have been developed with the machines, so the television as the lead medium. That has to change. You have to fit into the smartphone. But I think the most important thing is, in our education system, in the teams that we have, along with the technology experts, please include people who understand something called the complexities of human behavior. People who understand the functioning or understand the algorithms that are happening between our ears and use that into the algorithms that we create. And which means it's not just about looking at Generation X and Generation Y. It's not just about looking at cultures. But I think this machine has been collecting data over the last 600 million years. 600 million years of data has been collected by this machine and has been perfecting its algorithm over the last 600 million years. Bring that intelligence of nature and in human being into what you do. And that's when you actually will have a very new way of looking at communication in the digital world. Because of confidentialities, I can't tell you, whether it's e-commerce, whether it's medical adherence, whether it's physical activity, there are a whole lot of areas my team is working on. Sometime, when those works are over, I'll come back to you to say that this new way of looking at communication is the way of looking at digital communication. Thank you.